Okay, let's look at some types of chemical reactions. And in this short video, I'm going to discuss 5 basic types of chemical reactions. Very simple, basic chemical reactions that you should be able to recognize. And we're going to start with a very simple one called a synthesis reaction. And with a synthesis reaction, you have to hold on, I'm trying to get my pen. I can't do two things at once. Okay, a synthesis reaction, synthesis means to come together. And in a synthesis reaction, elements are coming together to form a compound that is larger than what it originally was. So I used A's and B's here just to kind of show you that when element A comes in contact with element B, we form a compound that is larger than what we originally had. And a prime example of that would be something like the synthesis of water. Hydrogen gas plus oxygen gas yields H2O. We have a simple hydrogen and we have a simple oxygen coming together, yielding, that's what the arrow means, a water molecule. And with the water molecule, you have hydrogens and oxygens that are chemically bound together. That's a synthesis reaction. Oh, we should balance this because we did that in the last program, right? Okay, so let's keep it balanced. Another example of a synthesis reaction could be something as simple as this. Sodium plus chlorine yields sodium chloride. Now, again, there's 2 chlorines here, so I'm just going to balance it for you. If you don't know how to balance a chemical reaction, I suggest that you go back and you watch the previous video. Alright, let's scroll down and let's go to our second type of chemical reaction. Oh, I gotta erase this, it doesn't scroll. Okay. The second type of chemical reaction is a decomposition reaction, and it is exactly the opposite of a synthesis reaction. In a decomposition reaction, you are decomposing something or breaking something down into some smaller pieces. And I'm going to write a few different ones for you so that you can see. Let's take something we haven't written before. Ammonia decomposes into nitrogen gas and hydrogen gas. Okay, let's balance this. We'll put a 2 here. We'll put a 3 here, and it's nice and balanced. If you don't know how to balance an equation, go back and watch the previous video, because I did it very quickly here. I did not do all the steps out for you, but if you did the steps, you would see that I balanced it just the way that you would do it. I'm just doing it a little bit quicker. Okay, in this reaction, you have an ammonia molecule. It's breaking down into nitrogen and a hydrogen. We can also do the same thing with water, opposite of what we drew in the previous examples when we were doing synthesis reactions. Water molecule breaking down into hydrogen gas and oxygen gas. You can put the little g's in here if you want to tell everybody you're talking about gases. Okay, that's a decomposition reaction. Here's one that's a little bit more complicated, but it's basically the same thing. Carbonic acid, H2CO3, breaks down into water and carbon dioxide. Okay, this one's already balanced. If you look, there's 2 hydrogens here, there's 2 hydrogens here, there's 1 carbon, and 3 oxygens, and 1 oxygen here, and 2 oxygens there. So 3 oxygens, 3 oxygens, it's already balanced. This is a decomposition reaction. It was 1 larger compound breaking down into 2 smaller compounds. Okay? Alright, let's go to the next one. That's 2 out of the 5 reactions that we'll look at. The next one is called a single replacement reaction. And this one is significantly more complicated than the last 2, but we're going to take our time and we're going to look and see what happens. In a single replacement reaction, you have a single element and a compound. Okay, so let's say you have sodium and calcium chloride. That sodium is a metal. calcium chloride is an ionic compound. It is made out of a metal and a nonmetal. Okay? Metal being calcium, chlorine being the nonmetal. Well, if you think of it like this, we have this beautiful girl. Give her a dress. And we have calcium. She's another girl, but I'll give her curly hair so we can tell the difference between them. And I'll put ruffles on her dress. Okay, and that girl right there is going to the dance with this guy. Bow tie. Okay, well, what happens is this girl with the straight hair kicks this girl out and decides that she wants to go to the dance. Poor guy has no face. Wants to go to the dance with this guy. So what ends up happening is this metal replaces this metal in the compound. So this calcium gets kicked out. If you want to see it in pictures again, let's see. Let's draw this guy again. Here's his bow tie. Give him some legs. And he ends up going to the dance with the straight-haired girl. He must like her dress better. And then the girl with the curly hair, and ruffles on her dress, goes by herself. Okay, all that drawing is making my hand a little crampy. So if we look at it in terms of chemistry, the metal replaces the metal. The girl replaced the girl. So up here we would have calcium being all by herself. Calcium is this girl, right? And sodium, which is this girl right here with the straight hair, going to the dance with the boy chlorine. Now, a couple things I want to point out here. This chlorine had a 2 as a subscript. This chlorine does not have a 2 as a subscript. Why is that? Well, remember, subscripts come from the partner's oxidation number. That calcium has an oxidation number of +2, and chlorine had a -1. So when we cross them down, that 2 went here. In sodium chloride, they both have oxidation numbers of +1 and -1. So they have subscripts of 1 and 1. Because we are writing new formulas, do not transfer the subscript from the reactant side to the product side. Rewrite your formulas using your crisscross method that we've been working on for a while now. Okay? Because this does not have a 2 down here, this equation is not balanced. So let's go ahead and do that. I'm going to change colors. I'll do it in green. Okay? I've got 2 chlorines here, so I'm going to put a 2 in front of that. That becomes 2 chlorines now. But now I have 2 sodiums, so I have to place a 2 over here. If you're having trouble balancing, make sure you watch the video on balancing chemical reactions. Okay? This happens to have a special name because it's a metal replacing a metal. And metals tend to lose electrons. Metals are losers. You know that because you look at your periodic table and they are on the left side of the periodic table. Let's see, is that the minus? Yeah. Okay, just get rid of that for a second. All of these elements on the left side of the periodic table lose electrons. They are losers. And because they lose electrons, they become positively charged. Positively charged ions. And positively charged ions are called cations. Now the thing that is doing the replacing, let's get rid of this for a second and bring back our girls. Okay, because the cation, the sodium, is a metal and it's a cation, is doing the replacing, This is called cationic single replacement reaction. I'll write that for you so that you have that somewhere. It's cationic single replacement. When a metal replaces a metal. When a metal replaces a metal, it is cationic single replacement. Now, the thing is, this could just as easily have been a non-metal replacing a non-metal. I have to erase this, so if you need to go back and look at it, scroll back on the tape. It's the beauty of the video here. Okay. In this case, we have A plus BC yielding BA. Let's draw it in girls and boys so you can see it a little bit better. Okay, I'm just going to draw their heads this time. Alright, let's say we have a boy now. Make him blue. And that boy is wearing a blue top hat. And he walks up to a girl. She doesn't look very happy, but you got a girl here. And you've got a boy that's wearing a bow tie. Keep them separate so you can see. Okay, so this boy is a non-metal now. And that non-metal is replacing this non-metal. Chlorine is a non-metal plus magnesium fluoride yields. Okay, so the chlorine is a non-metal, that's the boy. The girl is a metal, and this boy with this big hanging bow tie is another non-metal. When the non-metal replaces another non-metal, okay, now the magnesium is going to be going with, this girl is going to be going with the boy with this top hat. So this girl right here with the curly hair is now going to be going to the dance with the boy with the top hat. And this poor guy over here is going to be by himself. He's wearing his droopy bow tie. All by himself. Okay? So if we write it in chemistry, we've got magnesium, which is the girl, going to the dance with chlorine. I'm bringing that 2 down because magnesium has a +2 charge and chlorine has a -1. Not because there's a 2 here. That 2 comes from magnesium's charge. And fluorine is diatomic, so it maintains that 2 as a subscript. This is called anionic, it's an I, single replacement reaction. Okay, anionic because the anion is the negative ion. Fluorine is the negative ion. It's what's being replaced by this chlorine, which is also a non-metal. Anionic single replacement. Okay? For now, worry about whether it is single replacement or synthesis or decomposition or, as you'll see in the next example, a double replacement reaction. Okay? We'll work on anionic and cationic in class. Alright, let's erase those guys. Let's move on to our next type of reaction. And the next type of reaction is called a double replacement reaction. And in a double replacement reaction, now you have 2 compounds. Compound over here and a compound over here. Alright, let's take our boys and girls again so you can see what happens. I'll make the girls in red. Ooh, come here, pen. Here's a girl with straight hair. I'm only drawing the heads because of my hand gets cramped up. She's going to the dance with the boy with the top hat. And then we've got the girl with the curly hair. And she's going to the dance with the boy with the bow tie. Okay? It's like saying we have sodium chloride and magnesium phosphide. Okay, so sodium is the girl, it's the metal. Chlorine is the boy. Magnesium is the metal, it's the girl. Fluorine is the boy. Did I say phosphide? Fluoride. Sodium chloride and magnesium fluoride. Okay. Now, when they get to the dance, they decide they're going to switch partners. So when they switch partners, this girl goes and dances with this boy. The sodium goes and dances with the fluorine. So you end up getting a switch of dance partners. You've got the girl with the straight hair, and she's going to go and dance with the boy with the bow tie. And then the girl with the curly hair, she is going to end up dancing with the boy with the top hat. Okay? And they dance the night away. Now look what's happening here. This girl and this boy are on the outside. Outside. A and D. C and B are on the inside. Outers will go with outers, inners will go with inners. So sodium will hook up with fluorine, and magnesium will hook up with chlorine. So we end up getting sodium and fluorine together. Now, do not take the subscript that's in the reaction from the reactant side. You have to look at the oxidation numbers. +1, -1. Cross them down. Plus magnesium and chlorine. +2, -1. Cross them down. Now that chlorine gets a subscript of 2 because the magnesium is now giving the subscript to the chlorine. When you write formulas, you have to look at the oxidation numbers. Okay. I think there was something else I wanted to tell you, but now I can't remember what it was. Oh yeah, here it is. You see how these metals, these girls, are written first? Metals are always written first. Metals are always written first. Even though we're hooking these two up and these two up, B and C, you would think B would come first and then C would come second. No, ladies first always. The metals go first always. Same thing down here. Sodium was written first in this formula. It will be written first in this formula. And then magnesium is written first in this formula. It will be written first in its new formula. So the girls or the metals always get written first. Okay, last one. Last example of types of chemical reactions. And this one happens to be an organic reaction. It's an organic reaction because the first part of the reaction is an organic compound. It can be any hydrocarbon. Hydrocarbon is a fancy way of saying a compound that contains hydrogen and carbon. Here's carbon, here's hydrogen. And that's all that a hydrocarbon is. So it's a compound that contains carbons and hydrogens. It's an organic compound. And that organic compound will burn or combust in the presence of oxygen. So there's your oxygen. So any hydrocarbon plus oxygen will produce, and these two things, why did I write and there? Good question. I don't know why. Let's change that. I must be getting tired. Whoops. Hey. Okay, carbon dioxide and water. So these products always will be the same. They will always be carbon dioxide and water. In fact, these three things will always be the same. It will always be oxygen, yields, carbon dioxide, and water. This is the only thing that will change. So you could have CH4 plus oxygen yields CO2 and water. Okay, you could have C3H8 plus oxygen yields CO2 and water. We should balance these. Okay, but these three things, let's get a highlighter and let's make it big. These three things here and here never ever change. Okay? Let's balance this one just for fun. Let's balance this one because we haven't balanced the previous examples and you need some practice. So if we take a combustion reaction and we balance it, we've got one carbon here. Oh, let's draw the line. Okay, draw the line. Carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. One carbon, 4 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, see the 2 hydrogens right here? 3 oxygens, and 3 because there's 2 here and 1 here. Okay, that's where the 3 oxygens came from. Alright, starting with carbons, they're balanced. So I'm going to take, let's get a different color, let's do red. Okay, that's done. Now go to the hydrogens. Start on the side with the lower number. There's 2 hydrogens here and there's 4 over here. So I'm working on my product side. What number can I put in front of this water that's going to give me 4 hydrogens? Right, a 2. So when I do that, this becomes 4. But I have to recount everything. So I erase or cross all those out. How many carbons do I have? I still have 1. How many oxygens do I have? 2 here and 2 more here. That gives me 4. And then I see that I have my 4 hydrogens. Alright, so carbons are balanced, hydrogens are balanced, oxygens. This oxygen has to be a 4. I'm working on this side of my reaction, my reactant side, because that 2 is lower than the 4. So by putting a 2 here, crossing everything out and recounting, 1 carbon, 4 hydrogens, 4 oxygens, I now have a balanced combustion reaction. 1, 1, 4, 4, 4, 4. Okay? Is this guy balanced? No, it's not. Maybe we should do that one too. Alright, let's do that real quick. Let me just erase this. Okay? And let's balance this real quick. Draw the line. 2 carbons, 6 hydrogens, 2 oxygens. 1, 2, 3. 1 carbon, 2 hydrogens, right there is your 2 hydrogens, 3 oxygens. Notice it's 1, 2, 3, CHO, 1, 2, 3. It's always that way. Okay, so we've got carbon, changing colors, balance these carbons. Put a 2 here. Recount everything. 2, 4 plus 1 is 5 oxygens and 2 hydrogens. Now I'm going to balance my hydrogens. The 2 is lower than the 6, so I'm going to put a 3 here. Recount everything. 2 carbons. 4 oxygens plus 3 more is 7 oxygens. This is the same one we did on the last program. And we have 6 hydrogens. Okay, this is a 7, this is a 2. I have to multiply this oxygen by a number that will give me 7. In this case, it's 3.5. Okay, we've got recount, because I just put a coefficient in there, 2, 6, 7. It is balanced, but it doesn't look good because it is not balanced with the lowest whole number configuration. So because we have to make them lowest whole number ratio, I can multiply these numbers. Go back to green. 1, what happened? Don't panic. Okay, 1, 3.5, 2, and 3. 3.5, 2, and 3. I can take those numbers and make them into a whole number ratio. Remember, these numbers are mole ratio. So we've got 2, 7, 4, and 6. And I get that by just multiplying through by 2. Doubling the 3.5 gives you a whole number of 7. So if I double this, I have to double everything else in the equation. So my coefficients, to have the balanced coefficients with the lowest whole number ratio, is going to be 2, 7, 4, and 6. And remember, sometimes they will ask you, what is the sum of the coefficients? And when that, they mean add all of these guys up. So 6 and 4 is 10, 7 and 2 is 9, 10 plus 9 is 19. So the coefficient sum of 19. Okay? Alright, so we went over the 5 different basic types of reactions. You should be able to recognize them, and you should be able to write the products of some of those types of reactions. For instance, let's say, let's erase this. Let's say I gave you a reaction that looks like this. Calcium plus hydrochloric acid, HCl. First thing you should be able to do is tell me what type of reaction it is. Is it a synthesis reaction? Do I have an element and another element coming together to make something bigger? Do I have a decomposition reaction? In decomposition reaction, you're going to have one reactant and it's going to break down into 2 smaller reactants. Do I have a single replacement reaction, which means I have a single element and a compound? That's my answer. Or do I have a double replacement reaction, which is 2 compounds on the reactant side? Or do I have a combustion reaction where it's an organic hydrocarbon, carbons and hydrogens, plus oxygen? Well, that's not the case either. So this happens to be a single replacement reaction. Okay? And in a single replacement reaction, if you recall, you have an element that's by itself that's going to kick out one of these elements. So this calcium is a metal. It's a positively charged ion when it loses its electron. Didn't lose it yet. It's going to. In this particular compound, hydrogen is acting like the metal. It is the positive ion, and the chlorine is the negative ion. Positive one, negative one. So this metal is going to try to kick out hydrogen. And when it does that, hydrogen goes off by itself. And calcium is going to hook up with the chlorine. Calcium is going to hook up with the chlorine. Now, when I write the calcium and the chlorine together, I have to make sure that I write the formula correctly. And that includes writing your oxidation numbers in, crossing them down. Calcium chloride. Okay? Once that is done, once I've written my equation properly, then I can go on to balance it. And only then. You cannot balance it before you write your formulas correctly. So knowing how to write the correct formula, as much as we went over that in November and early December, you have to know how to write your correct formulas. Okay, so just to balance this real quick, I've got 1 calcium here, 1 calcium here. I've got 1 hydrogen, but 2 hydrogens. So I'm going to put a 2 in front of there. Now I have 2 hydrogens and 2 chlorines. Well, 2 chlorines, and I'm done. I want you to take some time and draw this out with the line and writing them down so you can see how that was done. I just don't want to go over 30 minutes in this video recording. So if you still need help with that, we will work on it during X time. Come and see me, and I hope this video helped you understand the 5 different types of chemical reactions.